January 2021 paper. Which of the following is not a vector quantity? Electric field, a vector quantity. Impulse, a vector quantity. Magnetic field strength, a vector quantity. But work done is not a vector quantity, it's a scalar quantity. So D is the right answer. The next, a particle of mass m has a momentum p and the kinetic energy ek. A second particle have mass m by 2 and momentum 2p. What is the kinetic energy? What is the relation? Look, the kinetic energy or Ke is half mv square. If you multiply, divide this equation by m, so it will be half m square v square over m. M square v square is the momentum square, so kinetic energy is equals to p square over 2m. This is the relation between kinetic energy and the momentum. So for the second particle, like what is the relation in according to this? The mass and kinetic energy inverse according to this relation. And the kinetic energy is directly proportional to momentum square. So mass is half. So if the mass is half, what happened to kinetic energy? It will be double. And if the momentum is double, what happened to it will increase by square, so it will become 4. So due to change in mass, it increases by 2. Due to change in momentum, it increases by 4. So what will be the total change in the kinetic energy multiplied by 2 multiplied by 4? So the kinetic energy will be 8 times the original value. So D should be the right answer. In 2016, an element oxygen was added in the periodic table. Which wrote proton? How many protons are there? 118. So A or B can be an answer. And then number of neutrons, you just have to take a difference. So 294 minus 118. So 176. So C should be the, oh, sorry, A should be the right answer. Then a particle has a mass of 3.17 kg. We want to convert into giga electron volt. Look, we have the formula E is equals to mc square. So if you want to convert like mass is in kg, first we'll get the energy, because like energy in giga electron volt is same as a mass in giga electron volt per c square. So first we'll get, when we substitute in this formula, E is equals to mc square, like 3.17 into 10 to the power minus 27 multiplied by speed of a light, which is 3 into 10 to the power 8 square. This will give an answer in joules. Like here we have energy in joules. Now, if I want to convert this energy joules into electron volt, so we know 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So if we want to convert the joules into electron volt, we have to divide by 1.6 exponent minus 19. So this whole value will divide by 1.6 into 10 to the power minus 19. This will convert this into electron volt. But electron volt, we have to convert into giga electron volt. Like, because we have electron volt and we want the final answer in giga electron volt. So then to convert electron volt into giga electron volt, we have to divide by 10 to the power, giga means 10 power 9. So we have to divide by 10 power 9. Here 1.6 into 10 power minus 19. So 10 power 9 we also divide. So when we divide, we will get energy. Actually, this will be energy in giga electron volt, but energy in giga electron volt is same as the mass in giga electron volt per c square. So which one it matches with? It matches with option D. That the mass first multiplied, we get this in joules, then divided by 1.6 exponent minus 19, we get in electron volt, and then divided by 10 power 9, we get in giga electron volt. We have uncharged capacitor and a resistor. So means the total voltage will divide between the capacitor and the resistor. Which of the following shows how the charge stored in the capacitor and potential across the resistor? So first, when the capacitor start to charge, the capacitor, the charge which is stored in the capacitor will start to increase. Exponential change will be there in the beginning, much faster change. So for charging graph, this will be the graph. And then because here what happened, as it is charging, voltage here will increase. So in comparison, voltage across the fixed resistor will decrease because they are asking for fixed resistor. So if total voltage is constant, so if more voltage here, less voltage across the fixed resistor. So this match with option C. A positron and a muon travel at the same speed through a magnetic field, and it is directed into, so you have first use, the positron is a positive particle. So if you use a left hand rule, your index finger represent the magnetic field. So your first finger or index finger should point into the screen, towards the screen. Your second finger represent the direction of the motion of the particle, where the particle is moving. So it's going up. So where your thumb is pointing towards, the thumb represent the thrust or the force. It is pointing towards the left hand side when you apply the rule. So it means the positron should move left. So it means the positron should move left. So which one positron is moving left, C or D? So either C can be an answer or D can be an answer. That is the first thing. Then the second thing is the curvature depends on the momentum. Higher means less deviation means greater momentum. They mention both are moving with the same speed. But muon is heavier and positron is like electron, which is lighter. So muon is heavy, positron is lighter. So means muon should have a smaller, like a radius of a curvature or more bend. And sorry, positron. And the muon, because it is having a greater mass, so it will have a greater momentum, so less curvature. So this is showing the positron and this is showing a muon. So C should be the right answer. So using their, because they have the same speed, so the momentum now depends on the mass. As the momentum depends on the mass, so the heavy one will have a greater momentum, so it will deviate less or less deflection, greater radius of the curvature. And positron, because it is lighter, so it will have a smaller momentum. As a result, it will show greater deflection. Question 7. Point charge of 2 microcoulomb and 3 microcoulomb are placed 1 meter apart as shown. What is the strength of electric? First, what is the direct? Because positive charges, so electric field direction at this point will be opposite. So when electric field direction at this point is opposite, so we should they will try to cancel out each other because like charges repel. So which part they're canceling out, either B or D can be an answer. Then how to work out the strength of electric field? Strength of electric field, it's E is equals to F over Q, or it is also KQ over R square. So if you want the strength of electric field at X due to 2 microcoulomb, the charge which is originating, so value of a K is 9 exponent 9, or value of the K you can also write as 1 upon 4 pi epsilon naught. So 1 upon 4 pi epsilon naught multiplied by Q, which is 2 micro, so 2 into 10 power minus 6, and divided by the distance, which is 0.4 square. The second value is equals to again KQ over R square. So it will be 1 upon 4 pi epsilon multiplied by 3 into 10 power micro 10 power minus 6 is there, and divided by distance will be 0.8 and square. Now, which one we will subtract? Always it should be a greater value minus smaller value. So when you work out, because here denominator is smaller, large denominator, so this is a small value and this one is a large value. So that's why B is the right answer rather than D. Because it's like greater minus smaller, so that will give us the net resultant electric field at point X. The wire is held firmly between the two poles of the magnet, which is mounted on the top of electric balance. Look, what will happen? A current is there, and the magnetic flux density. The reading, look, if the reading on the balance is increasing, it means the force will be upward on the wire. And if the reading on the balance is decreasing, means the force on the balance is upward, so force on the wire is downward. Because action and reaction forces are equal but opposite in direction. So magnetic flux between the magnet is 0.07 Tesla. When the wire is connected to a circuit, there is a current in the wire and the reading has increased. So the reading has increased. What does it mean? Like, look, the idea is that if you have a wire which is placed in a magnetic field and carrying current perpendicular. So because there is a current produces a magnetic field. So the magnetic field of a wire interact with the magnetic field of the magnet. So if the wire push the magnet downward, the magnet will push the wire upward. So if the reading on the balance is increasing, it means the force on the wire is upward. And if the reading on the balance is decreasing, because the wire is pulling the magnet and magnet is pulling the wire. So in that case, the force on the wire will be downward. So in this example, they mentioned the reading has increased. So if the reading has increased, it means the force from the wire on the magnet is downward. So force on the wire by the magnet will be upward. And then which rule you will use? You will use a left-hand rule, Fleming's left-hand rule, to work out the direction. So your index finger, because this is a south pole, this will be a north pole. So your index finger will point towards south. Your first finger or your index finger point towards south. Your second finger, your thumb represent the force. When you use the left hand, your index finger point towards south. Your thumb is representing force, which is upward. So where your second finger is pointing, your second finger is pointing in this manner. So your second finger is pointing from X to Y. So the current is from X to Y. So any option with X to Y is correct. Then what about the magnitude of the current? Magnitude of the force. The magnitude of the force is F is equals to BIL sine theta. The wire is perpendicular, so sine 90 is 1, so it will be BIL. B is the strength of a magnetic field, 0.07. I is the current, which is passing through. Okay, we need the current. And we need the F is equals to BIL. So we can use a formula F is equals to BIL. F is the force on the wire. So look, this reading was 1.5 and then it increased to 1.503. So how much extra force is exerted? 0.03 Newton. Or 0.003 Newton. So 0.003 Newton upward, 0.003 Newton downward. So this will be 0.003. Then B, the strength of a magnet. That is 0.07. I is a current we don't know, and L is the length of wire, 5 centimeters, 0.05. This will go there in division. So 0.003 divided by 0.07 times 0.05. That will give us the value for current. So it matches with option A. Is it clear, this one? So if the reading on the balance increase, it means the force on the wire is upward. If reading of balance decrease, force on the wire will be downward. A 6-volt is connected across two parallel plates. Which of the following shows electric field lines and equipotential? Equipotential surface, because the positive one is a higher potential. When we have the two electrodes, the higher potential is a positive one. So why this is wrong? Because higher potential is starting here. So B can be an answer, or This can be an answer. D. Then electric field is always directed from positive to negative. So this will be directed from positive to negative. So here its opposite is shown, that's why it is wrong. So D will be the right answer. An equipotential surface in a parallel plate, the equipotential surface are equally spaced. But if we have an isolated charge is there, the equipotential surface, the first two potential surfaces are closer. Equipotential surface means like work done is same. But as we move away from the charge, the spacing between the equipotential surface increase because work done is force into distance. As a force decreases, the distance between the potential surface will increase. A charge capacitor is connected across a resistor and a current in the resistor is measured. The graph of ln I and the time was plotted and the gradient was determined. Which of the following will give the capacitance? So we have I is equals to I naught e raised to power minus T over RC. That's a formula. If we take ln both sides, so ln I is equals to ln I naught plus ln e raised to power minus T over RC. Ln and e cancel out. So ln I is equals to ln I naught minus T over RC. If we rearrange the equation, ln I is equals to minus T over RC is plus ln I naught. Now we compare with the equation of straight line. So on y-axis, if we have ln I, on x-axis, if we have, because y is equals to mx plus c. So on x-axis, if we have t, what will be our gradient? It will be minus 1 over RC. And if we need c, so c will be equals to minus 1 over r into gradient. So minus 1 gradient into r, so that will match with option B. So this was January 2021 Unit 4.